Hello, today's lesson is on organic chemistry, specifically the formulas and the shortcuts for those formulas, and the many ways organic chemists use to draw molecules. So let's take one for an example. Here is a chemical that is an organic chemical because all the carbons, and it has a functional group of an OH right here, which makes it an alcohol. So this is an alcohol. So what is the name of this alcohol? Hopefully you remember from a previous video that we count the carbons first. 1, 2, 3, 4, 5, 6, 7 carbons in a row. That gives me hept for 7. And that in between each of these carbons is a single bond, so it has AN. And the OH functional group gives it the ending OL, and that's heptanol. But the OH group is on the 1, 2, 3rd carbon, so I have to say that also because it could be on any of these carbons. So I need to say this is 3-heptanol. Hept meaning 7, AN meaning all single bonds between the carbons, OL means there's an OH group, and 3 saying the OH group is on this 3rd carbon. So hopefully that's all review for you. So this is one way to draw a chemical formula, and this is the name for that chemical formula. Another way to draw that chemical formula is simply put carbons, hydrogens, and oxygens, and how many there are. So you might see this written as C, and there's 7 of them. H, well, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 hydrogens and 1 oxygen. So you also may see this written as C7H16O. But when it's written like this, I cannot tell quickly that that was an alcohol, or even if I thought it was an alcohol, I wouldn't know where the OH was. So there are some drawbacks to just writing the formula like this. And there's advantages into writing it like this. But because organic chemistry can have very long molecules, organic chemists find that this way, even though it's very helpful, is a long way to draw it. So they have some shortcuts to do that instead. One way to do the shortcut is, and keep the information available, is to write it like this. So they might say CH3, which stands for this carbon right here, which has 3 oxygen. Not oxygen, 3 hydrogens. And notice the next carbon has 2 hydrogens. So I would go CH2. The next carbon has an OH group and an H group. So we're going to sew CHOH. Then there are 1, 2, 3 more carbons with CH2. So sometimes I even can do this. 3 more CH2 groups. Wow, lots of different ways to do a shortcut. And the very last carbon is a CH3 group. So here's another way an organic chemist might draw the same molecule. There's a C with 3 H's connected to a C with 2 H's, connected to a C with an H and an OH, connected to 3 more CH2 groups, and then ends with a CH3 group. Wow, so another way to draw this molecule. Once again, that took a long time to draw, so there's even a shorter method to do that, and that's just with lines. Wow, so watch this. This is even shorter. So this is 1, 2, 3, 4, 5, 6, 7. So this squiggly line here represents the carbon chain. Each point represents a carbon. So this is 1 carbon, 2 carbons, 3 carbons, 4 carbons, 5 carbons, 6 carbons, 7 carbons. And notice I'm not going to put the hydrogens in there at all. Organic chemists think you know how to put hydrogens there and know how many there should be. So they're not even going to put them in this very shortcut method of drawing. But they do have to put this OH group. All right? So where does this OH group go? It goes on the 3rd carbon, 1, 2, 3. So then I have the OH group come off. And notice we don't even put a line between the O and the H, because that's just another shortcut they make. There is a bond between the O and H, they don't draw it. So, and they don't do these little circles here with the corners usually. I just kind of emphasize that. So it would just look like a line here, 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 and a line here, and the OH coming off. So that's the very shortest way to draw this molecule. 1, 2, 3, 4, 5, 6, 7, and the OH here. To draw the molecule and still know all the information about what kind of a functional group it is and what carbon that functional group is on. And as I said, organic chemists assume that you know that you have to add up to be 4 bonds for carbon. So this carbon here has 1 bond here, so it needs 3 H's. This one would have 2 H's to get up to 4 bonds. This one would have 1, 2, 3, just 1 H to get up to 4 bonds. This carbon already has 2 bonds, which are these lines, so it would need 2 hydrogens. This one would need 2 hydrogens. This one would need 2 hydrogens. And this one would need 3. It has 1 bond, but would need 3 more hydrogens. So this would be another way to draw the molecule. So let's do the reverse of it. I'm going to draw a molecule and see if we can go from the short to the long version. So here I have a molecule. Oh, let's see, how long should we make it? Okay, there we have it. And I'm going to put a double bond to an oxygen here. So how would I name this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, 11. Let's not go up to 11. Let's actually go ahead and erase this. Make it a little bit shorter because we didn't really talk about the prefix for 11. So let's count again. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I have 10 carbons there. So that is dec. They're all single bonds. So that's AN. This double bond to the oxygen is my functional group. And it's not on the end carbon, so it's not an aldehyde. It must be a ketone. And ketones have O and E for an ending. Now I have to say where the double bond O is, so let's count. If I count from this side, it would be 1, 2, 3, 4, 5, 6, 7, 8. But I always have to count from the shortest side because I could flip this molecule over. So this is at carbon actually 1, 2, 3. So always pick the shortest number. So this is 3 decanone, right? And the long way to draw this would be to write 10 carbons in a row. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I could put all the hydrogens. Notice I'm kind of cheating. I'm not going to draw the H at the end. I'm going to have the hydrogens coming out. Notice there'd be 3 at the end, 2, 2, 2, because if you count, each carbon has 1, 2, 3, 4 bonds. Now, I can't forget this double bond to the oxygen that came on the 3rd carbon. 1, 2, 3, double bond to the oxygen. Oops. If I have a double bond there, I now have carbon has 1, 2, 3, 4, 5 bonds. It cannot have 5 bonds. So I'm going to have to erase one of those lines. So I'm going to erase this one. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons, just like here in this top drawing. The double bond to the oxygen is off the 3rd carbon, and each carbon has 4 bonds to it. So there you have it, another way to show 3 decanone. So hopefully with a little practice, you can read and write these shortcut methods. Thanks for listening.